This example has a different denominator where the factors aren't just linear. So it's going to be a different setup. You have two factors in the denominator. So we're going to have something over x plus 3. Okay, now that's a linear factor, so it's going to be a over x plus 3. So remember, it's just going to be a constant when you have a linear factor in the denominator. Plus, and then the other factor in the denominator is x squared plus x plus 2. Now you might be asking yourself, well, what about factoring that? No, it's not going to factor, so not over the set of integers, so we're just going to leave it x squared plus x plus 2. But that is not a linear factor. That is a quadratic factor, right? The degree of 2. So our numerator can't just be a constant. It has to be 1 degree less. So we're talking about having an x term and a constant. So it's going to look like this, bx plus c. Now, why do we choose those letters? We're just going in order in the alphabet. So our first unknown was a, and so now we need two unknowns. We need a coefficient for the x term in this numerator and a constant, so b. That's why it's bx plus c. Now, I've never seen one of these go to like z, but we've got 26 letters to work with, so. But this is fine. Okay, that's how this setup is. Now we need common denominators. So our, oh dear, all that stuff's there. Mistake. All right, so we're going to have a times x squared plus x plus 2, and that's going to plus, and then we're going to have bx plus c, the other numerator, times, this drives me crazy. Well, I tried to erase my dots and I just get more dots. Okay, bx plus c times x plus 3. Okay, that's the setup then. So our numerator, we need this, 8x squared plus 12x minus 20. We need that when we start matching things up. And now we'll do the distributing. So we're going to get ax squared plus ax plus 2a plus, now we'll have to FOIL this out. So we're going to get bx squared plus 3bx plus cx plus 3c. And now it's a matter of matching up which coefficients go together. So here I have an 8 for the x squared term. So 8 has to equal, now I look for my x squared terms, a plus b. I run out of a little room there. Okay. Now the next one for the x term, I have a 12. 12 is going to have to equal, now I have to look for the x terms on the other side. So a plus 3b plus c. Okay? Those are all the terms that are x terms. And those coefficients have to add up to be 12. And then my last one, I've got a negative 20. So I'm doing different colors with different underlining to help you a little bit. That negative 20 has to equal the constants on the other side. So 2a plus 3c. Okay, that takes care of all our terms, so we're good. This one's a little bit different because you've got an AB equation, you've got an ABC equation, and then you've got an AC equation. So the first way I did it didn't work out very well, but I'm going to take and I'm going to multiply this equation by a negative 3. And I'm going to put it with that middle green equation. And so, indicate I'm multiplying there. I'm going to get those b terms to cancel. You might say, well, I wanted to cancel out the a terms. Yeah, but that's not going to help us very much because our other equation is an AC equation, so we need another AC equation. So when I distribute that negative 3, I'm going to get a negative 24 equals a negative 3a minus 3b. Those b's are going to cancel just like we want them to. And then that's going to equal, green here, negative 12 negative 2a, and those terms are out, plus c. Now something nice happens here. We get to take this equation then and use it with the blue equation. So we'll just recopy it. Negative 12 equals negative 2a plus c. And then that's going to get things to cancel for us, and we're going to be able to solve for something here. So we get negative 32 equals 4c, and so c is equal to negative 8. So we know what c is. Now it's a matter of going back and finding a and b. So I'm going to go back to my original equation with the a plus b. Oh, no, I'm not, because I only know c, don't I? Oh, okay, so I gotta find a. I'll put it into this green equation right here, and I'm gonna say then negative 12 equals negative 2a minus 8. So I'm taking this and I'm plugging it in right there. I should have done it in blue. All right. Add the 8, you're going to get negative 4 equals negative 2a. Divide by negative 2, you're going to get a equals 2. So now we know a and we know c, we just have to figure out b. Now I'm going to go to the first equation, which was 8 equals a plus b. And we're going to make that then 8 equals 2 plus b, or b equals 6. Okay, so the last thing we have to do is write the decomposition. So it's a matter of remembering what that looked like. So I'm going to go ahead and rewrite it so you can see it. But we had a over, I think it was x minus 3, nope, x plus 3, sorry. Plus 3. This is what we did at the setup, the very top. And then we had bx plus c over x squared plus x plus 2. Okay, and so now our answers, we know what a, b, and c are. They're right there for us. We just have to fill them in. So 2 over x plus 3 plus, what was my b? 6x. Notice that you've got to do that. That b is just the 6, but you still need the x there. Plus c, which is a minus 8, over, and then that denominator, which was x squared plus x plus 2. Okay? So that is an example of where we had factors in the denominator that were a higher degree than a linear factor.